We're going to look at another of the tests for series that have positive terms. So we just looked at the integral test, and now we're going to look at the direct comparison test. The direct comparison test is a really good choice if your series looks like it's some sort of number over a polynomial. All right? So let's take a look at how this test works. You're going to call the series that you're given a sub n. And then what you're going to do is choose another series, b sub n. Okay. Your strategy for choosing b sub n is that generally you're going to choose the same number and you're going to put it over the term with the biggest power in the denominator of a sub n. Generally, this is going to result in either a geometric or a p series. So here's how this works. We are going to choose a b sub n such that a sub n is between that and 0. Okay, so my b sub n is bigger, and if I know that the series, or the sum of b sub n, converges, then I know that my series is also going to converge. Okay, similarly, if I pick a b sub n, and my b sub n is smaller than the given series, than the given a sub n, and I know that b sub n diverges, so I have the smaller one is going to diverge, that's going to cause my series to diverge. So if the bigger converges, the series converges. If the smaller diverges, the series diverges. So this should look pretty familiar from 7.7 where we did the comparison test. Hopefully this is a little bit of a review for you and won't be too difficult to pick up this test. Let's give this a try with the first one. I have the series n equals 1 to infinity of 1 over n plus 2 quantity squared. I'm going to FOIL this out just so I can kind of get a better idea of what I'm looking at here. So I have 1 over n squared plus 2n plus 4. Now I know that n plus 2 squared equal to n squared plus 2n plus 4 is going to be bigger than n squared. And what I'm going to do is I'm going to do 1 divided by these. So I match this number up in the numerator. So I have 1 over n plus 2 squared and 1 over n squared. And when I do that, it flips my inequality over. Okay, so now I have 1 over n plus 2 squared is less than 1 over n squared. This looks like a p series. I have n raised to a number, and that p is a 2, which means this is going to converge. So I have everything I need to write this up now. Since 0, oops, set the C, 0 is less than 1 over n plus 2 squared, less than 1 over n squared. So notice there's no series symbols here. I'm just putting an inequality on those guys. And now I'm going to look at a series. So the series n equals 1 to infinity of 1 over n squared. So this is a p series. P is equal to 2, which is greater than 1. So this is a convergent p series. Therefore, my original series, n equals 1 to infinity of 1 over the quantity n plus 2 squared, converges by dct. So this is what your write-up should look like.